Right, this graph is the motion of a particle moving along a horizontal line. So in the first 3 seconds, it's moving forward, it speeds up, then has a steady speed, and then it slows down. And then from time t equal to 3 to 5 seconds, it was moving in the opposite direction. It was moving backwards, right? Moving backwards. And if you look at this, at t equal to 4, that's when it attained its maximum speed, okay, greatest speed in the backward direction, in the backward direction. And then from for 1 second, from time t equal to 5 to 6, it was at a standstill. Okay, that means the velocity is 0. Then it moves forward again. Okay? Right. Definitions. Acceleration is the derivative of the velocity, or you can think of it too as the derivative, second derivative of the position function. Okay, because if you take the derivative of the velocity, then you get the second derivative of the position function. Now, jerk is the derivative of the acceleration with respect to time. So you take the derivative 3 times for the position function. Or if you think about it, if you take the derivative of the second derivative of the velocity or the derivative of the acceleration, then you get jerk, the sudden change in acceleration. Okay. Near the surface of the Earth, all bodies fall with the same constant acceleration. That's Galileo's experiment with the free fall. Remember, it started with an apple, okay, which led to this equation s is equal to 1/2 gt squared. So that if the constant of due to gravity is 32 feet per second squared, it is in the English unit, like in terms of feet. And then if the g would be 9.8 meters per second squared, so that's the acceleration due to gravity in meters per second squared. So that if you have a free-falling body, it would be 16 t squared in feet and 4.9 t squared if it's in meters. Okay, figure 3.15, it shows the free fall of a heavy ball bearing that released from start at t equal to 0, and then it drops like that. Oops, wait, it drops like this. Okay, so how many meters does the ball fall in the first 2 seconds? So from here on out to t equal to 2, here it says it's 20. Let's see if that's the case. Okay, and then what is its velocity, speed, and then acceleration at t equal to 2 seconds. Okay, so s of t is 1/2 gt squared, and this g is the constant, which is constant of acceleration due to gravity. This is in terms of meters, so that means g is 9.8, so this whole equation would therefore be equal to s of t would be 1/2 of 9.8 becomes 4.9 t squared. So to answer letter A, we just take s of 2 to find the distance traveled for the first 2 seconds, and that's going to be 4.9 times 2 squared, which is 4.9 times 4. That gives us 19.6 meters. Okay, now letter B. So this is for letter B. We've got, what is its velocity? What is the velocity, speed, and acceleration when t is equal to 2? So first of all, we got to find what is s prime of t. S prime of t would be just 4.9 times 2t, or that's 9.8t. And if you want to find the velocity, that's s prime of t at 2 is also the velocity. At 2, you just substitute 9.8 times 2, which is 19.6 meters per second. Okay. And then it says what is its speed. So the speed is the absolute value of the velocity. So that's absolute value of 19.6 is equal to 19.6 meters per second. Then it's asking for the acceleration. Acceleration is the velocity of the derivative of the velocity, which is also the same as a of t. Okay, so you take the derivative, it's going to be 9. The derivative or it's also the second derivative of the s of t. Okay, so this is also equal to s double prime of t. Okay, which is acceleration, obviously is going to be 9.8 because it's acceleration due to gravity. So meters per second squared. Okay, now we have what we've got here is a modeling of a vertical motion. So you have a dynamite that's blows a heavy rock straight up with a launch velocity of 160 feet per second, about 100 miles per hour. It reaches the height of s equal to 160 minus 16t squared after t seconds. So how high does the rock go? Next, what are the velocity and speed of the rock when it is 256 feet from the ground on the way up and on the way down? Then what is the acceleration of the rock at any time during its flight after the blast? When does the rock hit the ground again? So let's break this down into parts to have an idea. This is how it looks like. So you blast the rock way up there, and then you move down, and then of course it stops and it goes back because of gravity. Okay? All right, so question, how high does the rock go? Well, if you look at this picture, you see that it reaches a height, and that's when the velocity is 0. So if we start with a position function, okay, so s of t is equal to 160t minus 16t squared, right? Okay, then we need to take its first derivative because that's the velocity, which is 160 with respect to t, okay, minus 32t. And then what will we do? Well, that's when it changes its direction, okay? So we will set this equal to 0 because that's when the velocity changes direction, okay? So set the velocity, which is the first derivative, 0. So this is all divisible by 32, or no, 16, I guess. Or 32, because 32 goes into 165 times. So anyway, if we set this equal to 0, what we're going to get is 160 equal to 32t. Divide both sides by 32. Okay, so t is equal to 5. So what does this mean? This is the time that it reached its maximum height. Okay, so how do we find the height? Well, you substitute t equal to 5 into the function s of t. So s of 5 is equal to 160 times t minus 16 t squared. You substitute that to 160 times 5 minus 16 times 25. And you will get the maximum height. And when you solve this, work this out, it should be equal to 400 feet. Okay, right? Okay, what are the velocity and speed of the rock when it is 256 feet above the ground on the way up and on the way down? Okay. Well, in order to find that out, we need to get the velocity. We already found the velocity function, but we need to substitute the time at which it reached this height. basically. So the first thing we need to do is to solve for the position function equal to 256. So solve for t for the equation s of t equal to 160t squared. No, 160t minus 16t squared. Okay, and you set that equal to 256. So what we've got is, if we rewrite everything, we're gonna get, I'll move everything to the right. Okay, and so what we've got is, it's gonna be 16t squared minus 160t minus 256 equal to 0. And obviously every term is divisible by 16, so let's divide term by 16. And we've got t squared minus 10t, right, plus 16 equal to 0. And this is t minus 8 and t minus 2 equal to 0. So we've got 2 times t equal to 2, 2 equal to 8. Okay, so from here, the first 2 seconds is when it's going up, and the t equal to 8 is when it's going down, right? So we have not answered the question yet. We have to find the velocity. All right, so velocity at 2 is the same as the derivative at 2. So that's equal to, what's the derivative? 160 minus 32t. So 160 minus 32 times 5. Okay. And what should we get here? We should be able to get 96 feet per second. 96 feet per second. And then on the way, okay, that's on the way up, and then on the way down, okay, what is its speed? Well, the speed is v of absolute value, which is the same, 96 feet per second. And then on the way down, it'll be what? It'll be v of 8, which is equal to 160 minus 32 times 8, which is negative 96 feet per second, and its absolute value would be the absolute value of negative 96, which is 96 feet per second. Okay, so that answers letter B. Letter C. What is the acceleration of the rocket at any time during its flight? Well, the acceleration is the same as the velocity's derivative, or the second derivative of s of t. So if you take v of t, as we said earlier, it's 160 minus 32t. Okay, so if we take v prime of t, that's equal to negative 32, right? So that's negative 32 feet per second squared. Okay, letter D. When does the rock hit the ground again? Well, if it's a position function, that means the position would be 0 feet. Okay, so s of t would be equal to 0. So if you set that equal to 0, 160t minus 116t squared, set that equal to 0, you pull out the 16, and then you get t, then you have 10 minus t. Right, so you have two values of t that will make it equal to 0. T equal to 0, which is the position, the starting position, and t equal to 10. And obviously we take t equal to 10 because that's when it blasts up, then it hits the ground again. Okay, so t equal to 10 seconds, right? Particle motion. At time t, the position of a body moving along the s-axis is governed by this equation. Okay, t cubed minus 16t squared plus 9t. Find the body's acceleration each time the velocity is 0. Find the body's speed, and each time the acceleration is 0. Find the total distance traveled by the body from t equal to 0 to t equal to 2. Okay, why don't you work this out and then pause the movie and then we'll come back to it. Okay.